Momentum is a vector quantity. Remember that a scalar quantity is one with only magnitude, while a vector quantity is one with both magnitude and direction. The direction of an object's momentum and velocity are the same. So momentum is the product of mass and velocity. We won't go into detail about why, but since mass is a scalar and velocity is a vector, the product of the two must be a vector with the same direction as the velocity vector. Let's visualize this with an example. Here we have a bird flying forward with some velocity. Here, this arrow represents the direction of the velocity vector. The bird will also have a momentum, given by its mass multiplied by this velocity. The momentum will also have direction, the same as the velocity's direction. It's extremely important that you understand that momentum has a direction like velocity. Let's understand why by looking at what happens if we try to add momenta together. When finding the total momentum, we add individual momenta together if they are in the same direction. This is something you'll be doing a lot when finding the total momentum in a system. It's similar to finding the resultant force on an object. So let's suppose we have two identical birds with the same speed. If the first bird has momentum of magnitude p, then the second bird will also have the same magnitude, p. So what do we do if we want to find the total momentum of the two birds? Well, in this example, both of the momentum vectors are pointing in the same direction, so we simply add them together. So the total equals p plus p, which is equal to 2p. But we won't always add momenta like this. When finding the total momentum, we find the difference between individual momenta if they're in opposite directions. Now let's suppose the birds are travelling in opposite directions. The two birds still have the same magnitudes of momentum, p and p, but this time we have their vector arrows pointed towards each other. Since this second momentum is opposite to the first, we'll treat it as a negative number. This means the total is now p minus p, which is equal to 0. So while the two birds have individual momenta, they have no overall momentum together. This is only possible because of how momentum acts as a vector. Make sure you're comfortable treating momentum as a vector for the rest of this topic. There's a lot of exam questions where you could lose valuable marks if you forget this. Let's look at one more way it's important to remember about momentum being a vector. The momentum of an object is also changing if the object is changing direction. This is similar to how we can change the velocity of an object just by changing the direction it travels in. For example, if we have a plane that's turning, its direction of motion changes. As this direction changes, the velocity changes. Remember that vector quantities have both magnitude and direction, so changing direction is enough to change the vector as a whole. Then we know that momentum is a vector that has the same direction as velocity. So if the direction of velocity is changing, then the direction of momentum is changing. This means that momentum also changes. This idea won't come up in your exam, but it's useful for helping with your understanding of the topic of momentum as a whole. In particular, the links between momentum and velocity, as well as how they both link to acceleration and forces. This idea won't come up in your exam, but it's useful for helping with your understanding of the topic of momentum as a whole. In particular, the links between momentum and velocity, as well as how they both link to acceleration and forces.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!